Mm. Good morning, ladies and gentlemen. I hope you guys are doing well. And two most important things in life, one of them is coffee, other one is self-care, especially as men. If we take care of ourselves, we can take care of our families. Oh, families? Yeah, family. Um, so, Mr. Coffee, sorry, Mr. Coffee, right now we need to focus. So, as you guys know that today's topic is related to linear functions, but I thought, ladies and gentlemen, why don't I relate it to a practical life example? How? Let's see. So this will be the first part of the linear functions video where I will derive a linear equation. We call it a linear function again because every x value has only one y value. That's why we can call it a linear function. So, guys, let's say for example, if I have an adjustable dumbbell, I'm sure you guys have used it at some point. Most of you have. If not, look forward to it. So, let us say if I have an adjustable dumbbell, okay, whose empty bar has a weight of 5 pounds, along with the two tighteners, 5 pounds, and then as we add the weights, which are 5 pounds each, one plate is 5 pounds. Let's say if I was to calculate the total weight of this right now, when there are two weight plates and there's the bar definitely, so I can say it is so the bar is like 5 pounds and then 5 pounds each for the plates. So 10 pounds for the plates and 5 pounds for the bar and the tighteners, which is 15 pounds. Ladies and gentlemen, we're gonna face a lot of practical situations where an independent quantity, in this case it's the plate, the number of plates, will affect the dependent quantity, which is the total weight of the adjustable dumbbell. This is one situation. Like, we can use it in many various situations where the relationship is linear. What do we mean by linear? Means the rate of increase of the dependent variable with per unit of the independent variable is constant throughout. Let us try to derive an equation for this. Now we can use it in other applications, like for example, calculating the cost of a ride fare, right? It depends on the rules and regulations, but in this video, we're going to be focusing on this example. So let us say that, and excuse me. So I have two quantities. One is number of 5 pound plates, then I have the total weight of the adjustable dumbbell. Let me erase this. I hope you guys know the topic so far. So of the adjustable dumbbell. So when I have no plates on the bar, what should be the weight, guys? The weight of the rod and the tighteners, which is 5 pounds. As I add 2 plates, what is the weight? It should be 15 pounds, right? And so on. But guys, don't add 1 plate at a time, and when you're working out in real life, you're gonna injure yourself. So when you have 4 plates, the weight increases by 10 pounds, right? With every 2 plates, the weight increases by or decreases by 10 pounds. If I I were to plot this, I want to make it a clean, neat and clean graph. Let me find a scale. Oh, here you are. Let's make it in a nice. Let's plot it in black. So I have the y-axis. I have the x-axis. So the x-axis is number of 5-pound, number of 5-pound plates, and the y-axis would be the total weight. I'll just write total weight. We already know we're talking about the total weight of the adjustable dumbbell, right? Let's plot it now, guys. So at 0, we have, let's say this is 5 pounds, and then we have 10, 15, 20, 25. Let's plot in that, and then we have number of plates. So we have 0, 1, 2, 3, 4, 5, and so on. We can add as many plates as we can, as we want. So at 0 number of plates, we have 5 pounds total weight. 2 plates, we have 15 pounds. 3 plates will be 20, and then 4 plates would be, how much was 4 plates? 25 pounds. Let me use the scale. So it's somewhere here. Do you guys notice one thing? Let me first join them so we can make our comments. Do you guys notice that if I connect these dots, it's not exact to scale, but it is. It's not exact to scale, but that's the line we are getting. Now mind you guys, this line of course will keep on continuing, and we already know that the rate of change of the dependent variable along with the independent variable is remaining constant. You see that? With every 2 plates, it's increasing by 10 pounds. Again, 2 more plates increases by 10 pounds. Like 2 plates, 15 pounds. 4 plates, 25 pounds. 6 plates, 35 pounds, and so on. That's how it's going to be. So what we'll do now is we'll relate this. We will make an equation, a linear function for this relationship. So let us calculate the gradient first. Again, this is stuff which should have been done like by you guys already, but let's go back to it. So the gradient, which is the m, y2 minus y1 or x2 minus x1, right? So to calculate the gradient, you can select any 2 points. In this case, I'm selecting 0, 5, 2, and 15. So the gradient is 15 minus 5 over 2 minus 0, which is 10 over 2, which eventually is 5. What is the significance of the gradient in this? The gradient again is the rate of change of the dependent variable with the increment or decrement of the independent. This means that the increment of 1 plate in the independent variable results in an increase of 5 pounds in the dependent variable. I hope that's clear. Now, to write an equation, you know, the straight line equation is. Now, in the next class, we're going to come to the different forms of the straight line equation. I don't want to make you guys bored. I know you guys want to do your coffee and continue stuff. So, y is equal to mx plus c, where m is the gradient. C is the y-intercept. Sorry about my writing. So, what is the gradient? 5x. What is the y-intercept in this case? Plus. This equation can be used to find the total weight for any number of plates. Now, if anyone wants to try putting plates all the way till infinity, if anyone has that much time in their life, go ahead. One more thing to notice here, guys, is that in this case, remember the domain of a function. In this case, our domain will only be values of x from 0 and above. Can it be less? Think about it. Can the number of plates be negative? I think that's a rhetorical question. So guys, thank you so much for watching, and this was the first part of linear functions. In the next part, we will come to the different forms of writing a linear function equation, and we'll solve one or two examples. And so that is it for today. Thank you so much, guys.